What that led to, at least in the case, the first deal I worked on way back when, our company implementing one of these, is a 26% increase in the productivity of a plant that was 40 years old. My background, again, chemical engineer. I went to Cornell. My, I'll call it generation of chemies. We're really focused on a couple things. One, I call it, weren't a whole lot of new unit operations or, the creation of new processes, but we were in a focus on automating processes. We had just discovered that we could utilize these, this compute technology for controlling systems. And one of the early projects I worked on was implementing a programmable logic controller into at that time, a 40-year-old plant. And these plants were typically, like all these processes, were more manually or analog controlled, where you had, operators who would go through an episodic observation of an event and then an episodic intervention. And it's, to the extent they were paying attention and not talking about, who's getting drafted in football, you would have certain control paradigms that would occur in these processes. Well, once you introduced a compute system into those environments, you're observing an environment, 60 times a second, and you're intervening, whatever is applicable for the process. So you have a much tighter control paradigm. And what that led to, at least in the case, the first deal I worked on way back when, our company implementing one of these, is a 26% increase in the productivity of a plant that was 40 years old. So if you start thinking about that in a broader scale, compute actually brings massive productivity and massive efficiency into almost any environment that it's placed into. And you take it from the process industries and then move it into different environments like an office. You have this same sort of productivity.